Welcome to an update from the Euroluna team on where we are here now in November 2009. Over the last period of time, what we've been doing is to explore further the option of our cubesat, Romit cubesat. And I have a little list up here of where we are right now in November. Our first module, and the one we are exploring most, is consisting of the processor, onboard computer if you want, a radio, camera module, power module, and solar cells. And I have the module here. In a CubeSat frame, with inside the first two bits, the processor and the radio. The navigation camera module is on its way. We have ordered it, and I expect to have it integrated into our command module, this physical one, before Christmas as such. We are running we're in the middle of making the onboard software. You've seen in a previous little series from me here about the radio and the processor actually sending back and forth through a ground station, a simulated ground station. What we've been doing over the last month or two is going very much into the second module here, which is the propulsion module, where we are going for an ion thruster, and we need a special power supply to drive that. The technical discussions are going on that level. We don't have an order yet. We have some companies we are discussing with and people who have experience in ion thrusting. And we are hopeful that we will manage to put something together. And I hope to have some more information about that in a very short time frame. This would lead us to a launch, possibly in 2010, of what we can say our first launch into space of a double module CubeSat, one with the command module on, and attached to that a propulsion module. To illustrate it, I have built a little box here. So you can say that our first launch would consist of something like this, with the command module being in front and the propulsion module behind. That, in a way, brings us back to our original design, which was based on chemical propulsion, which is what requires those very large tanks in our original design of the Romit for landing on the moon. So far we have met rather difficult times in getting on board a spacecraft with that sort of size, 30-50 kilograms, and the fact that we have chemical propulsion on board has been a stumbling block in our discussions with the launch providers. Whereas if we are talking about ion thrusters, the advantage is that the propellant on board is inert. It cannot explode, it cannot damage the main launch provider's satellite on board. So, this is where we are right now. The command module, whether this command module serves the Romit CubeSat or serves our original thought about our spacecraft, doesn't really matter. It needs to do the same thing, have the processor, the radio, the navigation, and so on. That's all the same. However, having gone down this route, we are also speculating about the future. And the future is really that if we continued along the line of the CubeSat, if we could make ourselves, I here call it a landing assist module, something to soft land us on the moon and have it in a CubeSat format, and something which would then afterwards make it possible for us to move on the moon, let's call it a rover module. And our current speculation is that we need 2 half modules, so 5 by 10 by 10 centimeters to have something on board which we could actually use for move. We do have a launch opportunity for something like this in 2011, though there are lots of uncertainties on that, of course. If we illustrate that in the same way with a little box here, half a CubeSat, module A, first rover module, our command module as we have it already, our second module B for rover module, the landing assist module, whatever that consists of in this moment in time, and a propulsion module at the end. To get us there, we would have a 4x1 CubeSat, which again falls into fairly much of a standard among the CubeSat launches, though slightly bigger than normal, but still within the standard operation of the CubeSat world. I try to illustrate that a little bit here by making a fanciful little description of how a landing module, a rover module might look. And if I put them together like that, you will be able to see my little illustration here, that we have some wheels on board which can be moved out. Well, now it's upside down, and therefore in the end we would have something that could roll on the moon together with our command module in the middle, and therefore be able to fulfill in this way, at least from a theoretical point of view, the requirements for the Euroluna X Prize. All this, you can say, at this moment in time is speculation. What we know and what we have is the command module. What we have is a fairly good idea about what will go into the propulsion module. And we may use those two together with some chemical propulsion in the landing assist module, and we may not be able to scale it down to the CubeSat size, but that remains to be seen. For the moment, what we're doing is really that we're working as much as we can at all on getting the propulsion module, the iron thruster, and the power supply needed for getting that propulsion module to deliver the thrust we need to get that ready for a launch next year. And that is where we're putting all our effort at this moment in time. Thank you very much for staying with us, and stay tuned.